Hello students, welcome to the course Network Theory. In the previous video, we have discussed the concept of star and delta network and the derivation of how we convert a delta network into Y network or a Y network into a delta network, right? So in today's video, we will try to solve one problem on star to delta conversion and another problem on delta to star conversion and one more additional problem to solve by yourselves. Okay. Let us look at the first problem. So before that, I try to recall on the formula how to make out this transition. Okay. So if you have to convert a delta to Y network. Okay. So each resistor in the Y network is the product of the resistors in the two adjacent delta branches divided by the sum of three delta resistors. Okay. Just you can recall if you are noted down in the notebook. Okay. What is meant by that? And then similarly Y to delta. Each resistor in the delta network is the sum of all possible combinations of Y resistors taken two at a time divided by the opposite Y resistor. Clear? So based on this, we'll try to solve the networks now. Okay. So just look at the first problem. Note down this. Find the equivalent resistance RAB using star and delta transformation for network shown in figure. So they are not mentioning either you have to do star to delta or delta to star. Based on the circuit, you have to take either of the one. Okay. So which will help you. So this is the network AB. Okay. So you have 5 ohm here. Then you have 6 ohm, 18 ohm, 6 ohm, 6 ohm, 18 ohm, 6 ohm. Like that. You have the combination of resistance, resistive network only. Okay. So what you have to do is the terminals between A to B. Okay. So how many resistors are there? This we have to replace it by a single equivalent resistance with a value. Okay. So that value you have to find out and you have to simplify. For that, the better option here is star delta. Okay. So you don't have any option for series and parallel here. Okay. So here you may be having one series, but later you can solve that. But other than that, you could not simplify this network, right? So that's why. So we will be solving this by uh, star delta transformation. Okay. So note down. So how to do this? Okay. So where we can apply now star delta. So this is the next question. Okay. So if you look at this diagram, okay. So from X, okay, we have denoted it, okay, Y and Z. Okay. It maybe looks like here I have denoted as a square. Okay. It looks like a square, but it is actually a three resistor in delta formation. Okay. See here, X to Y, one resistance is connected, Y to Z, another resistance is connected, and X to Z, another resistance is connected. Okay. So if you draw the same thing, you can using like this also, it is same, no? Just for orientation, we have made like this, right? So this is a delta network now. So you can transition this into a Y network. Okay. So you can have a Y network. Okay. So here one resistance, here one resistance, and then here one resistance. So when you make like this, what will happen? This resistance will come in series with this resistance. So whatever new resistance comes over here, so this will be in series with this, and this resistance whatever you have, it will be in series with these two resistance, right? So this complexity is removed. Okay. Then easily you can do the series parallel connection transformation like that. So as we have done in source transformation, source shifting, first step we will be applying star delta. Next step again we will apply series parallel, but first step only we could not apply the series parallel. That's why star delta is necessary. Okay. So we'll try to see this in the next slide. So let us convert the upper delta between the points XYZ into an equivalent Y. That's what I shown you there. So now we have to calculate that new values of, so in the derivation I have used ABC, right? So now instead of ABC I have RX, RY, RZ. Okay. So how you calculate that? It's a two adjacent resistance, right? So there is 6 ohm and 18 ohm is there. So if you look back, so what is the resistance here? Rx 6 and 18 is the adjacent. Ry 6 and 6. Rz 6 and 18. Okay. So and sum of all the three resistances. So that's what we have done. Rx 6 into 18 by 6 plus 18 plus 6. Okay. Use the calculator. So you'll get 3.6 ohm. Okay. You do it directly. Simply don't copy this. Okay. So perform that. Then Ry is equal to 6 and so 6 in between it is there, 6 into 6 by total resistance, 6 plus 6 plus 18. So denominator will not change, numerator little bit changes will happen. Okay, so by calculating you got 1.20. So third one you had same value 18 into 6, that's why the same as first value you are going to get the answer. Okay, so now you got the new y resistance, y resistor values you got. So now you have to draw that network in the y fashion. Okay, so first network what you have seen, you have copied that. Okay, copy that. Okay, I have not copied here, you have to copy first in the answer booklet, because okay, otherwise from where you got you will not understand. Okay, so do that. Since I have in the previous slide, I have not written here. Okay, so now we'll try to write that. Okay, so 5 ohm. Okay, Rx we have drawn here, it is 3.6 ohm. Then this is Ry 1.2 ohm, and then Rz 3.6 ohm. So what is remaining there? So 6 ohm was there, so it will be there here between Y and W. Look at the diagram. And then between Z and W you had two resistances. In the first step we have not done that, they are in series, so that's why it is added 6 plus 12 18 24 ohm. Okay, so now what we need to calculate, now between the A and B we need to simplify. Okay, so still what you can do, so that part you have to do now. Okay, so if you look at now A to here, so these two resistance are in series, 5 ohm and 3.6 ohm. And then when you look at these two junctions here, okay, so between these two junctions, okay, there are no intermediate connection is there, so this side no connection, this, so that's why these two resistances are in series you can consider, and these two resistances are also in series. Okay, and these two series resistance are in parallel with that. Okay, so like that you have to continue the simplification. Okay, so just I will show you in next diagram, copy this, hope it is understood. Okay, so 5 plus 3.6 8.6 ohm. Okay, added that. Then the series 1.2 and 6 we have added 7.2 ohm, 8.6 ohm. Okay, then 3.6 plus 24, it is 27.6 ohm. Okay, so next step is, now you can do right, so these two are in parallel now, so find out the equivalent parallel resistance, then these two are in series, you will get the final answer. Okay, so next slide we will get the final answer. The equivalent resistance Rab, so straight away we can do that, 8.6 ohm plus these two are in series, right, 7.2 parallel with 27.6. So two resistance in parallel can be done using a simple formula, right, multiply the two resistance. Sorry for the inconvenience. Okay, so these two are in series, so we can do like this, R1 into R2 divided by R1 plus R2. Okay, so this we can apply, 7.2 into 27.6 divided by 7.2 plus 27.6. Okay, so calculate this in the calculator. Okay, add with 8.6, so you'll get finally 14.31 ohm. So that is the resistance, single resistance between A to B you will get. Okay, so hope this complete transformation you understood now. Okay, so you have to identify where to apply delta to y, y to delta, that is the thing. Okay, so this is the first variety. Similarly we will do another problem where we will apply y to delta transformation. Okay, so note down this, hope you have completed. Okay, otherwise pause it and continue. Note down this second problem, using y delta transformation find an equivalent resistance between A and B for the network shown in figure. Okay, so you have two parallel y networks here. Okay, so star networks A and B here. Okay, 5 ohm, 3 ohm and 4 ohm, which is in parallel with 6 ohm, 4 ohm, and this is a jump, right, that means it is not connected to this line, 8 ohm. Okay, so now you have to straight away you have to find out the delta formation. Okay, how you find delta? So multiplying two resistances at a time, 5 into 3, 3 into 4, 4 into 5 divided by opposite. For this branch which is the opposite, 3 ohm. For this branch 4 ohm is the opposite. For this branch 5 ohm is the opposite branch resistor, so that you have to divide. Okay, so first you have to find out the product of two resistance at a time. Similarly same thing we have to do it for second y network. Okay, 6 ohm, 4 ohm and 8 ohm. Hope you understand. So we'll do that. So if you have understood, so what you can do is you can pause the video and you can calculate it and then you can check also. Okay, since it is first problem, go with me. Okay, no issues. So two star Y networks are in parallel. So first we have identified the network. So first network, I have separated it for solving. I named it as ABC. Okay, and it is RA, RB and RC now 6 ohm, 4 ohm and 8 ohm. Okay, this is the upper one. Okay, so this is the upper one I have considered first. Okay, so if you form the delta, so just try to draw the delta values I have computed in the next slide and that I have written here. So first you just draw the network. We'll see how you got these answers. Okay, so formula, you know what to do. So two resistance at a time, you multiply the product and then by opposite resistor just you divide. Okay, 6, 4, 8, that product you divide it by that, you will get the values of respective RAB, RBC and RCA. Very simple. So RAB is equal to, so directly I have done this product RA RB plus RB RC plus RC RA. First I told you to do this. Okay, the product. So 6 into 4, 4 into 8, 8 into 16, 6. Okay, so this total answer is going to come 24 plus 38 plus 48, 104. So you can do like that also product. Then each resistance you have to. So RAB, so which is the resistance opposite there? 8 in the network. Okay, so that's why 8 you have divided. So you got the resistance between A and B, 13 ohm. Okay, similarly you find RBC and RCA. So just 104 is the product you have already. No need to do again computation. Just 104 you can take. So you divide it by respective opposite Y resistor. You will get the RBC. See here, RBC formula I have written. Then total directly I have written 104 by 6. Opposite resistor is 6. That's why that. So you got the answer from calculator 17.33 ohm. Then you have the RCA. So just opposite resistor is RB. It is 4. So you'll get the 26. So which resistor you have to take here, that is very careful. Okay. So if you make little bit mistake, so all answers will go wrong. Okay. So you got the three values 13 ohm, 17.33 ohm and 26 ohm. That's what I have written in that slide. Okay. 26, 13 and 17.33 ohm. Okay. So similar way, another Y network is there. Same way we'll try to calculate. We'll give new names here X, Y, Z. So that RX, RY, RZ. Okay. So 5 ohm, 3 ohm and 4 ohm. Same way you calculate. So first we will find out the product here. In this problem I have shown like this. First I have find the product RX, RY, RY, RZ, RZ, RX. 5 into 3, 3 into 4, 4 into 5. Multiply this and add. So you will get 47 as the answer. Okay, so you do it. Okay, I may be going fast, so but you can have the option to pause and do the calculation. Clear? So then we need to find the each opposite side resistor. So if you want to find now RXY, okay, so write down this. I may not be written. Okay, so if you want to find RXY now, okay, which is between 5 ohm and 3 ohm, opposite resistance is 4. 47 by 4 you have to make 11.75 ohm. Okay, similarly if you have to find this YZ, that means opposite resistor is 5 ohm, so 47 by 5 you have to make, you'll get 9.4 ohm. Okay, similarly XZ you have to find out. XZ opposite resistor is 3 ohm, so 47 by 3, so 15.67 ohm. Okay, so that calculation I'm doing next. So this is how you do it. Okay, so very simple. RXY, how you got 47 by 4, 47 by 5, 47 by 3. Okay, so this is the calculation what I have shown in the previous. So once you have done this calculation and delta network, now you have to connect it back the network. Okay, two Y resistors connected in parallel should be shown now two delta networks in parallel because you have converted, right? And now you have to try to simplify parallel series, all these combinations. So this is the network now, simplified network. So in the first one, okay, so what you had in the first delta network, 13 was there between AB, then BC 17.33 and 26 you had. Okay, just look at the picture. Now the same parallel you got the second network 11.75, 9.4 and the 15.67. So how to do next? So what you need to calculate here between A and B, only we are interested in finding A and B. That means here nothing is connected, right? Any other branch is not connected. So what you can do first is, first you calculate all the parallel resistance here between 26, 15.67, 11.75, 13, 17.33, 9. So these two are in parallel now. First these parallel resistance should be calculated. Okay, so that we have done here. So calculation I have not shown, but I have directly done it. So you have to do. So formula is, if you have two resistance in parallel, so straight away you can use this formula, right? 1 by R1 plus 1 by R2, LCM taking after that, if you equate, it will be R1 R2 by R1 plus R2. So what you have done, these two I have multiplied, divided by these two I have added. So you got 9.77. Then 13 into 11.75 divided by 13 plus 11.75, you got 6.17. Okay. So then 17.33 into 9.4 divided by 17.33 plus 9.4. So you got 6.180. So now you got like this network. So now how it looks between A to B, you have to find out. So this is one branch is there now. This is one branch, and this is looks like another branch. Okay, so in this branch now two resistances are connected in series, so that we can add that. So that's why, so 9.77 as it is I have written, and these two I have added, 6.17 and 6.18 I have added. So it gives you 12.35 ohm series resistance. Now these two are in parallel, so that is computed here. Final step, RAB 9.77 into 12.35 divided by 9.77 plus 12.35, same formula. Okay, so final answer is 5.45 ohm. Very simple. As I told you, you need to know which transformation you have to use, delta to y to delta, and you have to use the formula correctly. Clear? I hope you have understood these two problems. Okay, if you have not completed, pause it and note down. Okay, so writing once is equivalent to reading 10 times. Okay, so network theory you have to read and practice. Okay, so very basic. Okay, so one more problem I will show you, which transformation to do. Okay, everything you have to do that. I have the answer also, I will show you, but you have to solve it. Okay, so this is the third problem. Find the equivalent resistance at AB using Y delta transformation technique for the circuit shown in figure. Okay, so all the resistance values are 30 here. Okay, so one calculation if you do, all will come same, but you have to identify delta network and Y network. Clear? So I quickly tell you. Okay, so you can stop here, pause here, and you do the calculation. Let it be wrong. Let it be wrong. Okay, and once you complete the problem, then you play the video. Okay, this is my suggestion. So pause it now and do the calculation. Okay, so I will continue with the explanation. Okay, so you come back and see the solution. So hope you have done. Okay, so you got some answers. Let it be wrong, no, don't worry. So how to solve this now? So if you look at the diagram, so straight away it looks like here one delta network is there, right? So this is your identification. So how you get the network here? You have one Y network. Okay, here one Y resistance. So this is comes like this. Okay, next again this network also you are reducing. So what you are making? You are finding the Y network, and then here one Y network. Okay, no need to do middle one because already this will simplify. Then third one is this. So you consider this. So your intention is to do the network reduction, just not to apply star delta transform. Okay, so this is how it looks like now. So now between A to B, so you have to look at which are in series, which are in parallel. You have to do the calculation. So this is the first step. If you understood this, next is easy. Okay, so just try to show you next figure. So if do it calculation. Okay, at least at this stage, if you have not gone through first step, so after this clue also at least you can go through. Okay, so let us convert each of the delta network. So we have given names there, ABC, BD and CF into an equivalent where F is isolated node. Okay, so where is this diagram? Yes, here it is. So first we'll calculate here. One calculation if you do enough. Okay, so three delta networks are there, right? So each of the resistance we need to find RA, RB, RC in the first delta upper one. All values are same, so you'll get the same answer. Okay, 30 into 30 by 30 plus 30 plus 30, 900 by 90 equal to 10 ohm. Once you go on, all values are same only, 10 ohm. Similarly, in triangle BDE also you will get straight away 10 ohm. Okay, no need to do. So that's why it is a 5 marks question. So much calculation is not there. Only you are doing the reduction. So first step, note down the same problem again and do this calculation. So you got the values now. So now connect the network now in Y fashion. So this is a network. So what I told you that 10 ohm, 10 ohm, 10 ohm. Then this side you had one network 10 ohm, 10 ohm, 10 ohm. Another side this 10 ohm, 10 ohm, 10 ohm. Okay. So now looking at this diagram, so we need to find resistance between A and B. Only this is our interest. So in this path, so how many path you have? Here you have one 10 ohm resistance. Here you have one 10 ohm resistance. Then in between you have two nodes here. Okay. So this is a junction here. Nowhere you have don't have the junction, right? So here you have two resistance in series in this branch and another branch. So you have four resistances are in series. Okay, coming over here, this point, right? Current will flow in this direction and this direction. Whereas this node F is isolated node. Okay, it is not connected here or closed. That's why you can discard this node. Okay, it does not play any role in calculating the equivalent resistance. Okay, so F is isolated, so it is not considered. So now the equivalent resistance. So 10 ohm, whatever I have copied here, and then these two are resistance in series 10 ohm, 10 ohm, 20 ohm I made, and these path I have four resistances. So the calculation is 40 ohm I have shown. Okay, and then again I have 10 ohm resistance here. It is shown. So now do the parallel connection. So if we write here as a formula, so 10 plus 20 and 40 are in parallel. So again formula R1 into R2 by R1 plus R2 straight away done plus 10. Okay. So after doing calculation, you'll get the answer 33.33 ohm. Okay. So this is the problem. Okay. So at least first two you have seen. Third problem without seeing if you do, so your confidence would have increased. I hope you have done that same manner. Okay, so with this we are completing the problems on star delta transformation. Okay, so in the next video we'll begin with the mesh analysis. Okay, so that is a very basic concept. Okay, so that will start in the next video. Thank you. If you like the video, please click the like button. Okay.